Okay, so jot down those points for me. And then again, we'll bounce over to the graph paper and we'll take a look at what the graph looks like. That says 1, 2, 3, 4, and 5 next to it too. You just can't see. There it is. All did. Okay, ready? All right, so I'm going to jump over here to my graph over here. And we're going to take a look at each one of these points. So I'm going to start with point A, which is 5 pi over 2. Okay, so on my graph, I'm going to start by finding pi over 2, which is this angle right here. Okay, so start by finding your angle. Pi over 2 is right here. All right, then what I'm going to do is I'm going to go from my center point, which on these graphs is what they call the pole, and I'm going to go from that center point out my radius. So I'm going to go down this line 5 circles. So I'm going to count out 1, 2, 3, 4, 5. And that right there will be point A. Okay, so find your angle first, then count from the pole out the number of circles that they've given you in the radius. All right, let's try another one. So number 2, I'm working at 2 pi over 3. All right, so here's my 2 pi over 3 angle right here. All right, and I'm going to go from the pole, I'm going to count out 3 circles. So from my center point, I'm going to count out 1, 2, 3 circles, and that's going to be my point right there. So that right there is B. So you can kind of work them backwards. Start by finding the angle, then count out the number of circles that they've given you on the radius. Any questions on those two? Okay, the difference on number 3 is that they've given me a negative angle. Okay, so this time I'm trying to find the angle negative pi over 4. Okay, so if you look at your kind of cheat sheet there, I know that negative pi over 4 is the same thing as 7 pi over 4. Okay, so these two angles are the same. Okay, so back over here, I know that, if I can find my pencil, that this is also negative pi over 4. Okay, that's right there on my little cheat sheet. So I'm going to be working on this angle right here. Here's the line that I'm working on right here. And I'm going to go out 4 circles. So from my pole, I'm going to go 1, 2, 3, 4. So that is point C. Okay, any questions on any of those? Okay, number 4 is a little bit different because the radius is negative. Okay, when the radius is negative, I'm going to count in the opposite direction. Okay, so on number 4, it tells me that I'm working with the angle of pi. That's this one right here. Okay, so rather than counting 4 towards pi, I'm going to count 4 in the opposite direction, which is going to send me down this line over here at 0 pi. Okay, so I'm going to still count, 2 circles. I'm going to count 2 circles towards 0 pi. So I'm going to go 1, 2, and there's point D right there. Okay, so if you have one with a negative radius, you're going to go in the opposite direction. Okay, let's try another one. So I'm going to go on number 5. I'm going to go to 5 pi over 4. So here's 5 pi over 4 right here. But because my radius is negative, I'm going to go in the opposite direction. The opposite direction will have the same denominator. Okay, so from 5 pi over 4, I'm going to be working at 1 pi over 4 right up here, and I'm going to go out 3 circles. So I'm going to go out from my center, 1, 2, 3. So that will be point E right there. Okay, so negative radius means I want to go in the opposite direction, which will have the same denominator up here. Okay, last one with F. I'm working with negative 2 pi over 3. All right, I know negative 2 pi over 3 is the same thing as 4 pi over 3. Okay, so there's my original angle right there. All right, so I'm going to go right here and say I know I'm working at negative 2 pi over 3, which is the same thing as 4 pi over 3. Okay, so negative angles, we measured this direction. Okay, so here's my line that I'm working on for my angle. But rather than come down that line, because my radius is negative, I'm going to go the opposite direction, which is going to put me up here at the same denominator. So I'm working at pi over 3, and I'm going to go out 4 circles. So I'm going to go out 1, 2, 3, 4, and that one right there is F. A little bit of line there. Okay, any questions about how I graphed them? Okay, so let me stop right there just for a second and kind of show you where we're going. I also know this angle right here is negative 5 pi over 3. Okay. All right, just watch mine for a second. We called F negative 4, negative 2 pi over 3. But do you see how I could also call this point 4 and pi over 3? Or 4 and negative 5 pi over 3? Okay, so all of these points actually have 4 different names. Okay, and that's where we're going to go next, is I'm going to try to name the same point 4 different ways. Okay, here we go with the alarm again. All right, so back on your notes. What I'm going to do is I'm going to give you 2 points that we're going to name 4 different ways. Okay, so I'm going to ask you to find the other 3 names for these 2 things. We're going to do 7. I'm going to give you 3 with negative pi over 4. And for 8, I'm going to do negative 4 with negative 5 pi over 3. Okay, so on your worksheet it'll give you a table and it's going to look like this. Alright, so I'm going to start over here by putting the number of the question. and then it's going to have a column to write the positive name, and a positive negative, and a negative positive, and I'll move over here in just a second, and a negative negative. Okay, so every point has 4 names. I'm going to find the other 3. Okay, these are not easy. These are kind of hard, so get some good practice with these for sure. We'll practice some more another day too. Okay, the first thing I need to do, so I'm going to start with number 7. The first thing I need to do is figure out which column this point goes in. Okay, so this point right here has a positive radius and a negative theta. So it's going to go in this column right here with a positive radius and a negative theta angle. Okay, so step number 1, figure out which column your given point goes in. And sometimes they'll give it to you in the table. That's okay too. Okay, step number 2, I'm going to go back to my graph paper and I'm going to graph that point. Okay, so I'm going to use a new graph. I'm going to jump down here to this one. Okay, and I'm going to write on this one that this one is my notes, numbers 7 and 8. I'm going to graph both 7 and 8 on this piece of graph paper. Okay, so I'm going to graph 3, negative pi over 4. Okay, so back from my cheat sheet, I know this angle right here is negative pi over 4. I know negative pi over 4 and 7 pi over 4 are the same angle. All right, so I'm going to go from my pole right here, and I'm going to go out this angle right here that we've just labeled. So this one right here. I'm going to go out 3 circles. So from my pole, I'm going to go out 1, 2, 3. That one right there is number 7. Okay, so back to my table, the radius is not going to change numbers. Okay, the radius is always going to be the same number. What's going to change is the positive and negative sign. So on this one, my radius will still be 3. And on these 2 columns, my radius will become negative 3. Okay, so again, your radius is not going to change number. It only changes sign. Okay, for my angles, the denominator will always be the same. So if you're starting here with a pi over 4, then this is going to be something pi over 4, and this is going to be something pi over 4, and this is going to be something pi over 4. Okay, so all of your angles will be some version of pi over 4. Okay, so let's start with this one. I said I'm working at an angle of negative pi over 4. What's the positive version of that angle negative pi over 4? That's right, good, 7 pi over 4. Good, so negative pi over 4 and 7 pi over 4 are the same, so my positive angle will be 7 pi over 4. Okay, so that's another way to name that same point. Okay, so if I were to go and graph 3, 7 pi over 4, I would end up right back here in this same spot. Okay, now with a negative radius, I'm going to go in the opposite direction, but again, have the same denominator. Okay, so what's my positive angle going to be with a negative radius? 3 pi over 4. That's right, good. So again, same denominator, 3 pi over 4. Okay, so opposite direction, same denominator. Okay, now look at your little cheat sheet graph. And what's the negative angle name for 3 pi over 4? Get your graph. That's right. Yeah, good. Right here. So 3 pi over 4 is the same thing as negative 5 pi over 4. So my negative angle will be negative 5 pi over 4. Okay. Again, they'll all be some version of pi over 4. Okay. Here we go again. Okay. Okay, give number 8 a try. Okay, so step number 1, put it in the right column. Step number 2, graph it. And then step number 3, see if you can find the other 3 names. Okay, so try number 8. Try number 8. First, put it in the right column. Then go over to your graph paper and graph it. No hurry, but when you're ready to check your point, that's where your point should be. No hurry, but when you're ready, check yours. That was kind of fast. Okay, so again, all the way across, the radius will stay the same number. What will change is the positive and negativeness of it. And your angle will always have that same denominator. So if you're working with one and all of a sudden your denominator changes to like a pi over 6, something might be going wrong. Okay, so your angle should always be some version of pi and then over 3 for this one. Okay, questions on that one? Yeah? Yes. So negative 2 pi over 3. When I did this one, I'm working with the pi over 3 right here. Okay, so I graphed my negative radius, which put me here. So that would be at 4 with 4 pi over 3. Then my other name for 4 pi over 3 is negative 2 pi over 3. So I had a positive radius and a negative angle of negative 2 pi over 3. Yeah, good question. Good. Other questions about those? Again, I think these are hard because you have to kind of know all the different names of all those different angles. So be sure you get some practice on those. Those are kind of hard. Okay, the last thing we're going to do is convert between polar and rectangular. So I've got 2 formulas that I'm going to give you for these. Let me put this together real quick. Okay. All right, the last thing we're going to do is convert. And let me start with going from polar to rectangular. We'll talk about what those words mean. Let me start there, and then I'll move over. But it says rectangular, so convert from polar to rectangular. Okay, so polar is your r and theta, and rectangular is your x and y. Okay, so rectangular is just a fancy name for an xy point that you're used to graphing on a graph. Another fancy word that you'll see for that rectangular sometimes is Cartesian. I can write that one in print. That's kind of a weird word right there. So that's another just kind of fancy word for rectangular, meaning an XY point. Occasionally you'll see that word Cartesian, not very often, but I just wanted you to know that it's just a fancy word for an XY point. That's all it is. Okay, so these two formulas come from your unit circle. Okay, I'm going to put a big star next to it so you can go back and find your formulas in a few minutes. Sorry. Bring it blank for a second. All right, so I'm going to be given r and theta. I want to find x and y. Okay, so think back to your unit circle, and I know that x works with cosine. Okay, so from my unit circle, I can say that x is equal to r cosine theta, and I know y works with sine, so I can say y is equal to r sine theta. Okay, and those two formulas right there will give you your answer of your points. Okay, so let me work an example for you. So I'm going to start with the point 2 and 5 pi over 6. So this is why I had you write down the unit circle stuff. So grab your cheat sheet back out where you can see all that unit circle stuff. Don't forget about all students take calculus. Okay, so let's talk about that. All right, so let me start by plugging in. So I'm going to plug in this for r and this for theta. All right, so I'm going to say that x is equal to r cosine theta, and y is equal to r sine theta. So just plug them directly in. Okay, so for my xy point, I'm going to keep my 2, and I'm going to go over to my unit circle, and I'm going to find the cosine of 5 pi over 6. Okay, so first I'm just going to find 5 pi over 6. So 5 pi over 6 is right here in my second quadrant. Okay, because of all students take calculus, what do I know about cosine in the second quadrant? Negative. That's right. Good. So in all students take calculus, remember it tells you where things are positive. In the second quadrant, only sine is positive. So if I know this answer is going to be negative, okay, now I'm going to go look at pi over 6, and I'm going to grab my x value. All right, so at pi over 6, I'm going to grab my x value, which is the square root of 3 over 2. Okay, so negative square root of 3 over 2. Okay, let's go ahead and do sine before we keep going. All right, so y equals 2. All right, again, this time I know sine is positive. Sine is positive, so I'm going to have a positive, and I'm going to find the sine at pi over 6, which is y. All right, so at pi over 6, I'm going to go get y, which is 1/2. Okay, now because we're multiplying, I can let my 2's cancel out everywhere. So I'm going to get that x is negative square root of 3 and y is 1. So my point will be negative square root of 3, positive 1. Okay, so plug directly into those formulas, which is kind of the easy part. The hard part's going back and finding those values on your unit circle, so watch out for that. Okay, any questions on that one? Just need to kind of go back a long way in the memory bank on finding those values. Okay, last one. Let's go the opposite direction. So this time I'm going to convert between rectangular, so I'm going to go the other way, to polar. Now, there is a way to use those same formulas, but I'm going to give you formulas that are a lot easier to use. Okay, so this time I'm going to go from xy to r theta. Okay, big star so that when you go back on your test you can find the formulas easily. All right, the first formula I'm going to use to take x and y and find r is the circle formula that we used back in conic sections. Okay, so I know that a circle is x squared plus y squared is equal to r squared. Okay, so I can use that formula right there. I can plug in x and y and find r. Okay, so again, just from those circle formulas way back in conic sections. Okay, I'm going to need to take the square root after I plug things in, so watch out for that. Okay, then to find theta, I want to put x and y together. So think back to unit circle, and we always said that the tangent of theta is equal to y over x. And so I can use that formula to put y and x together to help me find theta. Okay. I am going to want to get theta by itself. Do you remember what we do to move the tangent over? What do we move a trig function with? Sorry. Inverse. That's right. Good. Okay. So really, theta is going to be equal to the inverse tangent of y over x, which just means I'm going to take a value, and then I'm going to go find the angle. Okay. So I'm trying to find an angle. Okay. There is one kind of tricky part to this that I'll show you here in just a second. Okay, so let's work one. I'm going to go with number 10. I'm going to work with the point 3, negative 3. Okay, so I'm going to take xy, 3, negative 3, and I'm going to change it into an r and a theta. Okay, so again, just make sure you know which direction you're going. So what you're given and what you're trying to find. Okay, so to find r, I'm just going to plug into this formula right here. All right, so I'm going to start with 3 squared plus negative 3 squared, which is equal to r squared. All right, don't forget when you square a negative, it becomes a positive. 9 plus 9 gives me 18. And I'm going to let you leave r as the square root of 18. You don't need to plug it in and find a decimal, and you don't need to change it into 3 square roots of 2. I'm okay with just the square root of 18. You can leave it just like that. Okay. All right, over here is where we get a little bit trickier. Any questions on r before I go to this one? Okay, pay close attention to this part. This part gets a little tricky. All right, I'm going to plug into this formula here. All right, so I'm going to say that theta is equal to the inverse tangent of negative 3 over 3. Okay, so theta is the inverse tangent of negative 1. Okay, here's what's kind of tricky about this. If I think about my tangent value, and I think about all students take calculus, I know tangent has to be positive here and here. Okay, so I know my answer is not in the first or the third quadrant. Okay, to figure out if it's in 2 or 4, I'm going to need to go and graph this point. So remember, this is just an XY point. Okay, so I'm going to go over here on my graph, and I'm going to graph 3, -3, and my point ends up right there. So now I know that I need an angle that is in the 4th quadrant. Okay, so graph your point, and that will tell you which quadrant your angle is going to be in. Okay, now I'm going to look back at my cheat sheet. I'm looking for where tangent is 1. All right, so tangent is 1. These are my tangent values over here on the side. So tangent is 1 at pi/4. So in the 4th quadrant, I could call my over 4 angle either one of these two things. I'll take either answer. It does not matter to me. Okay, so I'm going to say that theta is 7 pi/4, or if you would prefer, -pi/4. Oops, you can't see, I'm sorry. There we go. Okay, you do not have to answer both. Just choose one. Whichever one you prefer is perfectly fine with me. Okay. All right, so my answer then is either the square root of 18 with 7 pi/4 or the square root of 18 with -pi/4. Okay, again, you don't need to answer both. One or the other will be fine. Whichever one you prefer. Okay. All right, that was kind of a lot today, and it's a lot of tricky stuff, so be sure you get some practice with that. So flip over to worksheet number 2 for me. Worksheet number 2, it's a one-sided worksheet. Looks like this. Okay. Label that top graph. That's where you're going to graph numbers 1 through 4. Okay, we're going to omit completely number 5. So worksheet number 2, omit completely number 5. It draws one of the pictures, and we'll come back to that in a few weeks. Okay, so then you can use this graph to help you with numbers 6 and 7. Okay, so the top graph can help you with 1 through 4. The bottom graph you can use for 6 and 7. Omit number 5 completely. And then on this bottom section down here, let's take off B. You don't really need that for 10 and 11. So 10 and 11, just find the r and the theta on 0 through pi, from 0 to 2 pi. You can take off the -pi to pi part of it, okay? And again, I'll take even a negative angle answer on that. Whichever one you would prefer is fine. As long as you can convert to r and theta, I am good. Okay? Very good. Okay, so again, tomorrow we'll learn one